Good morning to all. Any doubt in last class? No. Okay, no problem. Okay, and now we are going to discuss about cyclotron. What? Cyclotron. Okay. While writing about this question in your examination, just to follow 5 steps. Okay. First one, use. Second one, principle. Third one, construction. Fourth one, working. And the fifth one, limitations. Limitations of the cyclotron. 5 steps are there. Use, principle, construction, working, and limitations. Okay? Then, first, listen properly. In your textbook, there are different complicated diagrams are given, but just you follow one diagram. Okay? Enough that. Listen. Okay. Then D's high frequency accelerating voltage. Source of protons. Uses this one, high energy photon beam. This is target. This is DP, deflector plates. Okay, this is enough. This is a simplest diagram. Okay. Okay, listen. This is very important. Repeated 5-mark question. 100% repeated 5-mark question. No question paper without this question. Okay. Same percentage. Very important 5-mark question. Repeated question this. Okay. Listen. This is the simplest diagram of cyclotron, not biclotron, cyclotron. That is very important. Okay, listen. First, use. What is use? This is the device. It is used to accelerate the charged particle. Remember in your mind. It is used to accelerate the charged particle to gain high kinetic energy. Okay. And also this is called high energy accelerator. High energy accelerator. Okay. Then it is invented by Lawrence. Keep in your mind, Lawrence and Livingston in 1934. No need year. Okay, no problem. Lawrence, invented by Lawrence and Livingston actor. Livingston actor. Like that. In 1934. What actor? For example, to remember in your mind. Lawrence. Okay. Actors. Lawrence and Livingston. Not actor here, to remember like that. Okay. Lawrence and Livingston in 1934. Okay. Then principle, very super and important principle. This already you have studied about this. When the charged particle moving in normal magnetic field, remember? Very good. Yes, you are correct. When the charged particle moves normal to the magnetic field, that means a perpendicular to the magnetic field, it experiences one of the force. Yeah, you are correct. Magnetic Lorentz force. Very good. You are correct. Its magnitude. First completed. Second. Its magnitude. F is equal to, this is magnetic Lorentz force. Its magnitude F is equal to BQV sin theta. BQV sin theta. Magnetic Lorentz force experienced by the particle when moving in the magnetic field normally. That is important. Okay. BQV sin theta. Normally or with respect to with an angle, no problem. Magnetic field, charge of the moving particle, velocity of the moving particle, angle between magnetic field and very good. Magnetic field and moving particle with velocity v. That is the angle. Okay. When it experiences maximum force, yeah, if theta is equal to 90 degrees, that means perpendicular. When charged particle moving perpendicular to the magnetic field, it experiences maximum force. F is equal to BQV because theta is equal to 90 degree, sin 90 is equal to 1. Okay? Clear? Follow this one by one, okay? Because of very important. And teaching, if you listen properly line by line, word by word, you can understand how many percentage? 85%. I am correct or not? Remaining 15%, just to turn the papers on glance. That's all. You can understand fully. That means 100%. But only you can understand 85%. At the time of teaching only. Okay. So listen properly. Then two things are completed here, and third one, construction. Okay, come on. You can write only about the circuit diagram or schematic diagram by only. Okay, only the explanation of the diagram regarding physics. Okay, diagram. Okay, already done. Now you can write the explanation of the schematic diagram from the diagram only. Okay, listen. Here, cyclotron consists of hollow metallic sphere. It is divided into two groups, or divided into two sections, first, second, in the form of D, capital letter in English. D, I am correct or not? So that is called Ds. Okay? Then, for example, like this. 2 Ds. Like this 1D and like this 2 Ds. Okay, like this. See here like this or like this. Okay. Then source of protons or source of ion or source of proton, for example, placed here. That means between 2 Ds or center of the Ds here at this point. Okay, correct? At this point, source of protons or source of ion. Here, for example, source of protons. Okay, then the system it is placed between 2 poles, one pole and the other pole. 2 poles of the strong 2 poles, here one pole, here one pole. 2 poles of the strong electromagnet. The system placed between 2 poles of the strong electromagnet. Here 2 poles, north pole and south pole. What is the purpose of 2 poles? To produce, magnetic field. To produce magnetic field, uniform magnetic field. That is simply denoted by capital B, uniform magnetic field. So here uniform magnetic field, see the board. Here uniform magnetic field acts the system, one pole beyond the board, other pole here of the electromagnet. So uniform magnetic field acts like this, perpendicularly or normally to the plane of the Ds. Very good. Or plane of the board. Okay. Then. So this I told you deflector, plate, and target. Okay. Then this 2 Ds connected with high frequency oscillator. That means or high frequency accelerating voltage. That means source of AC. What is AC? Like same alternating voltage. High frequency accelerating voltage, high frequency alternating voltage. That means it is connected with the source of AC or DC, alternating current, or high frequency electrical oscillator. Okay, no problem. You can say any one of the word. Okay, that's all. There is any remaining? No. Okay. I will tell you the purpose of target and DP. Okay, not now, later. Okay, right. Then construction, okay. Then working. That means operation. Okay, listen. Now we are going to discuss about working of cyclotron. Very simple this. Okay, listen. Source of proton or source of ion. Okay. When the positive ion, that is important, of charge Q. When the positive ion of charge small q and mass small m ejected from the source. Listen properly here. When the positive ion, this is source, when the positive ion of charge q, mass m, ejected from the source, it is accelerated. Already 2D is connected with the high frequency accelerating voltage, no? Or high frequency oscillator, no? That means the source of AC. So when the positive ion of charge q, mass m, small m, emitted or ejected from the source, it is accelerated with the help of electric field, not a magnetic field, with the help of electric field towards 1D having positive potential or negative potential. Very good, because this is a positive ion. Yeah, it is accelerated towards the D having the negative potential at the instant. Clear? Because this is positive ion, it is attracted by the help of negative potential. So towards accelerated with the help of electric field towards 1D having negative potential at that instant. Say here D1. This or this, no problem. D1. Okay. So already told you. For example, here this source of ion. For example, proton coming out like this. Okay. Yeah, this is starts to moving, traveling. So here we present. I am correct or not? Of the particle. So it is experiences Maddie Lorentz force or not? Yeah, compulsory experiences because of it is in moving. Clear? We presents. Yeah. So it is experiences Maddie Lorentz force because of already the Maddie field acts like this, perpendicular to the plane of the disc. Like this. Particle moving here like this. I am correct or not? So it is experiences a Maddie Lorentz force. So it moves very good in circular path. Okay? Because it is experiences Maddie Lorentz force. No, that is the principle of cyclotron. I am correct or not? Yeah, it is moves now in circular path. Okay? So like this. Now by the time the ion arrives between the gap of the two Ds, okay, it starts moving. Now the polarity of the Ds gets reversed. For example, first this is positive, for example, or this is positive, this is negative. Okay, moves towards the negative potential. The having negative towards the D having negative potential at that instant. I am correct or not? Because this is positive ion. Now the polarity of the D's gets reversed. First this is negative and positive. Positive and negative. Alternately reversed. Gets reversed. Now the ion already it is moving in circular path. Now this ion, okay, positive ion, just moves or just circulates or traveling towards or generally now this ion accelerated towards other D. Okay, for now say D2. First D1 having negative potential. Next already told you, so alternately the polarity of the D's gets reversed. Now so it is circular path. Again, due to with the help of high frequency oscillator or electric field, the positive ion moves once again accelerated towards other D. Like this. With greater velocity. Moves again in circular path. Other D. First this D and second other D. First already moves in circular path. And again, when the polarity of the D's gets reversed, it is moves in circular path again or accelerate towards the other D with greater velocity. First, comparing previous radius. Okay, here velocity low, radius also low. But at this point, velocity increases or radius of the circular path also increases. Okay, so again and again polarity gets reversed. So it is continuously this positive ion moves in spiral path. That is important, not circular path. Moves in spiral path because Purida solrada. Listen properly. Source of ion thus first D vanduruchu. Maddie field normal aaguthu. Move circular path. Already here acting electric field. What is the purpose of electric field? Accelerating voltage. Okay. So, இப்படி வந்த உடனே ஆக்சிலேட் பண்ணதா அப்ப எதிரியே வராம இப்படி மேல போயிட்டு இருக்கு. கரெக்ட்டா? மேல போயிட்டு இருக்கும். அப்ப velocity என்ன ஆகும்? இன்கிரீஸ் ஆகும். சொல்றது புரியுதா இல்லையா? ஓடி மேல இப்படி போயிட்டு இருக்கு. கரெக்ட்டா? So the positive ion or for example proton, the particle proton moves very good, spiral path with increasing radius and also velocity. So like this. Okay. So again and again, velocity of the particles gradually increases. Radius also increases. Okay. So the path acquired by the charged particle in cyclotron, it is spiral. Okay. And coming near the, come on, listen, that's all. And coming near the edges of the D with the high energy, for example, proton, it is taken out with the help of deflector plates. DP, that is called DP. And finally, it is allowed to hit the one of the target. What is the purpose of allowed to hit the target? No need now. Discuss later about this, okay? In next unit. That means in nuclear physics, not the next unit, okay? So taken out with the help of deflector plate and allowed to hit on the target. That's all. Okay, listen properly now. Now, okay, remember in your mind, when the charged particle moves perpendicular into the magnetic field, it experiences, very good, magnetic Lorentz force. Its magnitude already written in the board. Okay, so this magnetic force provides a necessary. Anyone? Yeah, centrifugal force. Okay, because listen, this is nucleus. Around this nucleus, electrons are revolving. I am correct or not? In circular path around the nucleus. What's the reason for this? Yeah, here centrifugal force acts. Okay, I am correct. That's only the electrons revolving in circular path. Otherwise, no chance. Okay. Similarly, this magnetic Lorentz force experienced by the particle under the influence of magnetic field, it is equal to centrifugal force. That means, listen here, listen, this magnetic Lorentz force provides necessary centrifugal force. That's all. Centrifugal force. Okay. What is the magnitude of magnetic Lorentz force? Very good. See here. F is equal to BQV sin theta. Already told you about this terms. Okay, be about B, Q, V and theta. Centrifugal force mv square by r. Okay. Velocity of particle, radius of the circular path, mass of, already told you, particle or ion, positive ion. For example, proton here. So, F magnetic Lorentz force is equal to centrifugal force, no. Therefore, BQV sin theta is equal to mv square by r. Okay. Here theta will be 90 degree. What is the reason? Magnetic field with the help of a strong electromagnet. I got or not? Magnetic field acts perpendicular to the plane of the D's. So here movement of the particle like this. The magnetic field acts like this. So both are perpendicular to each other. So it experiences maximum force. I am correct or not? Therefore, theta is equal to 90 degree. Sin 90 is equal to 1. Therefore, BQV into 1 is equal to mv square by r. So, BQV is equal to mv square by r. Therefore, V cancel, no? V square cancel. So remaining BQ is equal to mv by r, small r. Therefore, R is equal to mv by dq. Radius of the circular path of the ion, positive ion. mv by bq. M mass of ion, v velocity of ion or velocity of the particle, b active magnetic field, uniform magnetic field, q charge of the particle. Charge of the particle. Here, for example, charge of proton. For example, charge of proton and v velocity of proton, m mass of proton, for example, here. Okay, that's all. Okay, listen here. Here, which is the constant here? M. Okay. V changes, increases, and also V not increases, changes. That's all. Let us consider changes. R changes, but M, B, Q constant. Therefore, this is constant. I am correct or not? So R is equal to constant into B. No, R directly proportional to B. That's all. So, what is the meaning of this? What is the meaning of this? Listen. Like this. I am correct or not? Yeah. Starting velocity low. I am coming here. Velocity will be very high. Okay. At this point, edges of the D. I am correct or not? So, velocity increases. Radius also increases. R increases, radius of circular path increases, the velocity also increases of the positive part or positive ion. Okay, R is directly proportional to V. Clear? Any doubt? Okay, then listen, just see again one by one. Use principle, not principle. Construction, working and limitations. Working, okay. Okay. Come on, see one by one. Here a bit, this side only, this side only. Okay. Okay, then very important thing in cyclotron. That means very important in cyclotron operation is resonance. Resonance. We are using resonance books only. I am correct or not? For need, yeah, that is resonance. Okay, sir. What is the resonance? Not need book, volume 1, volume 2. The meaning of resonance, that is different. Okay? What is resonance? Matching. ஒரு ஃபேமிலியில் ஹஸ்பண்ட் ஒய்ஃப் ரெண்டு பேரும் இன்றைக்கி கல்யாணம் நாளைக்கு டைவர்ஸ் அந்த மாதிரி பண்ணுவாங்க. நிறைய இடத்துல அந்த மாதிரி நடக்கும். என்ன ரீசன் நீங்கள் நினைக்கிறீங்க? ஃப்ரீக்வன்சி மேட்ச் ஆகாது. நான் என்ன நினைக்கிறனோ அதை அவங்க நினைக்க மாட்டாங்க, அவங்க என்ன நினைக்கிறாங்களோ அதை நான் நினைக்க மாட்டேன். அவங்க ஒரு பக்கம், நான் ஒரு பக்கம். ரெண்டு பேருடைய அந்த எண்ணங்கள் மேட்ச் ஆகாது. கரெக்டாக? அதனால தான் இன்றைக்கி கல்யாணம் நாளைக்கு டைவர்ஸ் அந்த மாதிரி போய்ட்டு. No need about divorce, okay? Come to the point. Resonance means, for example, that's matching. What is matching here? Frequency. When the frequency of circulating particle in uniform magnetic field, it is equal to constant frequency of electrical oscillator. Now, resonance occurs in the cyclotron. Okay? That is very important. Okay. So, resonance frequency, we can simply say that resonance frequency. Already you have studied about frequency of the particle. That means in the title, presented in your textbook, page number, I think 177. I am correct or not? Take and see. Quick. Take and see in your textbook. I think page number 177. The equation number 3.59, I have correct or not? I am correct or not? Yeah. F is equal to B Q by 2, very good, 2 pi M. Okay, from that we can write the frequency of oscillator F as B Q by 2 pi M. Okay, uniform magnetic field, charge of proton, for example here, charge of positive ion, mass of positive ion, or here mass of proton, 2 pi, this is constant, okay? Okay, so generally we can written as for frequency of the particle, F is equal to BQ by M, 2 by M. Just keep in your mind this term, okay, this formula. So regarding this question, new textbook, F oscillator is equal to BQ by 2 by M, okay? Or generally keep in your mind this formula only, enough. Okay, now, and time period of oscillation. Time period of oscillation. Point varadu illaya? Then oscillation. Idha sollala illaya? Oscillation, like that. Time period of oscillation. It is simply denoted by, yeah, capital T. Time period of oscillation. How do you write? From this, that's all. Because F is equal to 1 by T, okay? This is general form of a frequency. T is equal to 1 by F, okay? T is equal to 1 by F. Okay, come on, tell me now. You can write for the formula for T, that means the time period of oscillation. Yeah, very good. You are correct. 2 pi M by BQ. This is for frequency, this is for oscillation. That means, sorry, time period for oscillation. Time period of oscillation. 2 pi M by BQ. Okay, don't confuse this. Okay, small f is equal to BQ by 2 pi M. Caps T is equal to 2 pi M by BQ, that's all. Because the formula for F, general formula, small f is equal to 1 by T, that's all. Okay? Clear? See, 1 by 1 again. Any doubt? If you have any doubt, you ask me, no problem, okay? Clear about resonance? Yeah. Frequency of this particle, okay? Is equal to, yeah, constant frequency of electrical oscillator, that's all. Now resonance occurs, that's all, in cyclotron. Resonance means a matching, frequency matching. Clear? Any doubt? Okay. What is final step? Remember or not, there are 5 steps now. Use, principle, construction and working. Last one? Yeah. Limitations. Okay, come on, tell me. There are 3 points. First point. Now, limitations of cyclotron. 3 points are there. This is final step. Speed of the ion is limited. Speed of the ion is limited. ஒரு particular level நம்மளால பண்ண முடியாது. Okay, limit பண்ணணும். Limited is. Speed of the ion is limited. Okay. Second one, electrons cannot be accelerated. Why? Because of this is negative charge, no? Yes. Electrons cannot be accelerated with the help of cyclotron. Third one, uncharged particles cannot be accelerated. Okay? Because of already studied about in use. It is a device it is used to accelerate the charged particle to gain large kinetic energy. Correct or not? Yeah. So from that you can write third point. Uncharged particle cannot be accelerated. Okay? Okay. Then next one. We can write the formula for kinetic energy also, because of this is a use, I heard or not? It is a device, it is used to accelerate the charged particle to gain high energy, that means high kinetic energy, I heard or not? So we can write here the formula for kinetic energy also. That is very, very important. How will you write? How, sir? Try yourself. From these equations, try yourself. Come on, try yourself. This okay? I repeat, this okay? Kinetic energy of the charged particle. Kinetic energy of the charged particle. Okay. What is the basic formula? What is basic formula? Yeah. KE is equal to, yeah, you are correct. Of M square. Okay. How do you write this? Yeah, see that. Come on, see that. B Q is equal to mv by r. Okay, see that. BQ is equal to, already written in the board. Okay, from BQ is equal to mv square by r. That's all. V and V square cancel. Remaining BQ is equal to mv by r. Okay, mv is equal to BQR. Okay, that's all. How? Come on, try yourself. Yes. Yeah, we can change this. I mean, multiplied by m and divided by m. Okay, so 1 by 2, m into m square, v square by m. Okay, so 1 by 2m, m square, sorry, into v square. Okay, 1 by 2m. What is the formula for m square v square? Come on, that's all. Okay, square on both sides. Okay, so b square, q square, r square. Therefore, Ke, kinetic energy of the charged particle, b square, q square, r square by 2m. That's all. Okay. Ke is equal to b square, uniform manifold charge of, here for example, here proton, this is radius of the circular path, mass of the proton here. Okay, that's all. Clear? Any doubt? Okay. Okay, next we are going to discuss about one problem relevant to, that means based on the cyclotron. Very, very smallest, simplest problem, nothing else, very simple this. Okay. Clear? Any doubt? Okay, next we are going to discuss about one problem. Okay. Okay. Take a textbook, volume 1, like this. Page number 183, example. Don't see solution, okay? Right. Put your hand like this on the solution, okay? Don't see your solution. That is a method of practice to solving the problems, okay? Read one by one and extract the data and write in symbols and just you find a formula and go to solution. That's all. First, suppose a cyclotron is operated to accelerate the protons here. That is a charged particle. With a magnetic field, 1 Tesla. Okay, so how do you write in symbol? Given data. Magnetic field 1 Tesla, no. So compulsory you must write in symbol only, not in word. So just you use capital B. Okay, 1 T Tesla. unit of magnetic field. Calculate the frequency which the electric field between the two D's could be reversed. Already done here, okay? This 2 D's is connected, high frequency oscillator, no? Yeah, here calculate the frequency in which is the electric field between two D's could be reversed. So we must calculate frequency, okay? That's all. Come on. Only given magnetic field, okay? But keep in mind the value of magnetic field and the name of the particle, okay? Your turn. That is important. Okay, what is the formula? Formula, yeah, F is equal to BQ by 2 pi m. That's all. Okay. Solution, F is equal to BQ by 2 pi m. Okay, F is equal to B. Okay, 1. Q, charge. But here charge of proton, yeah. 1.6 into 10 power minus 19 coulomb. For proton, that means plus 1.6 into 10 power minus 19. Okay. For electron, negative charge. That's all. But the magnitude same. Minus 1.6 into 10 power minus 19 coulomb. Okay. But here proton. Okay. 2 into 3.14 because of pi value. M. Yeah, not given. Mass of proton. Okay. What is mass of proton? Yeah. Mass of a proton 1.673 into 10 power minus 27 kilogram. That's all. This is mass of a proton. Yeah, substitute in this formula directly. Okay. Yeah, simplify this 1.6 into 10 power minus 19. 8 to 6.28 into 1.673 into 10 power minus 27. Yeah, try yourself quick. That's all. And after simplifying, you get 15.3 into 10 power 6 Hz, I think. Okay, that's all. Substitution, first data, and for given data, formula, and substitution, that's all. In substitution necessary 2 or 3 steps compulsory, okay? So after we getting 15.3 into 10 power 6 Hz or 15.3 megahertz, not mega means 10 power 6, okay? Clear? Okay, thank you.